All right, so you're getting Superman dot fly. So because you're doing the same thing I did. Superman is equal to new person,
Hmm.
and it shouldn't be equal to a new person. It should be equal to a new superhero.
Oh.
Yeah, I did the same.
Oh, yeah, yeah, yeah.
Yeah,
Because we
just spreading
changed it.
bad examples of what to do.
There we go.
There you go. You're rocking and rolling.
Thank you.
Okay. Let me know if anyone else has any issues. We'll take a look. The errors are, good at this point to troubleshoot. I was teaching a class last night on jQuery, and I intentionally created errors so that with the introduction of jQuery, they would see the most common like 5 errors. So I just went out of my way, created a bunch of errors on the fly, and I was like, how do we fix these? Because I can guarantee you, you're going to have errors. The sooner you see them, the sooner you fix them, the less frustration you're going to incur into your life. So, um,
My
same.
my first class that I had,
Yeah.
she actually had us do the exact same thing for
Mm-hmm.
jQuery. She gave us like a list, and she's like, "Okay, these are all screwed up. Go find out what's wrong."
Yeah. That's one of the first things you should teach, like when teaching JavaScript, is how to fix the errors because you're going to get tons of them. All right. I think we're almost there, right? 24. I think we're looking for solid 20. I think we're at 23. Let's wait for two more. 24, 25. We're done. Good. Sweet. Let's go to the, all right. So we did the fly, up, up, and away. Now, what we can do is also override previous functionality, right? So person itself, if I just expand person, did have this greet method, right? It's got a greet method. We could use the greet method, right? So if we wanted to use the greet method, right, if I just console log that and say, hey, I want to do superman.greet, uh, Owen, let's do that. Let's see what it does. Let me clear this out. And because I'm still console logging Superman, just stop console logging. And one more time, it didn't save it. All right. All right. Hi, right? So once again, we had the ability to do a walk before. I now have the ability, once again, to do any one of these methods, pass it in something, and then it will greet us as it should greet us, right? Well, what if I say, I don't know, Superman here, he's got a different kind of greeting when he greets someone. So we can say, hey, you know what? You're going to have another greet. And your greets is to console, and I'm going to put in our other person too, right? Other person, because we want to, I guess, keep things kind of consistent. Console log. We're going to use those backticks. Hey, greetings, Earth. Oops. I didn't make up this stuff. Uh, I mean, other person, right? So apparently he was about to babble Earthling. They don't want to give it away that he's Superman, right, from another planet. So if we do this again, right, save it, clear it. So what we see is we can override, if we want, the previous methods that we inherited. Okay, we can override those. So I'll give you a minute to catch up and extend your superhero with the one method. Here we go. I'm just going to give my own emojis, but I feel like everyone's going to just choose someone else's. See, now I know what Matt meant by multiple emojis means now I got to do math. How many emojis of that and then that? I'm really bad at math, by the way. 12, 13, 14, 15. Okay. 16, 17, 18, 19, 20, 21. We're 21.
Somebody found Patrick from SpongeBob.
Oh, did that? Is that what he is?
Yeah.
That's sweet. 9, 21. There we go. I think people now we definitely have more students than there are emojis there. All right. So, cool. Now that we were able to extend it, that's great. What if we wanted to call within our new method a method that existed in the parent class? So I see that there's this walk right here, right? And I was like, hey, I see walk. And what I'd like to do is leverage the walk also, but I want to do that inside. I'm just going to minimize this. Inside of my Superman. So I'm going to create a new method here called walk, right? All right, so now we're kind of overriding the previous walk, right? Here's a walk here. We're making the decision to override it. But at the same time now, we're going to kind of do this. I'm going to use this keyword super, and I'm going to instantiate the instance of the walk from the parent class. So this keyword super here, I'm going to put up here as a new keyword, super. And what super is represents here is kind of the parent class. You know, when we instantiated the other person dot name, we passed in other person dot name, and we were able to then elicit the name from that object. Super here, the fact that you see the dot, a dot always indicates that the thing before it is an object, right? We know that. So that must mean that super is an object. And then the next question would be, well, what object is super, right? If we deduce that we are creating a walk here and that this isn't going to be the same walk, right? We're not going to call the same walk within the walk. That's just, it's like a concept of recursion. I'm going to call walk, it's going to call itself, it's going to call itself. This would be a perpetual kind of looping construct if we actually called this walk. So when we call super, we're calling the other super. So I'm going to do this. I'm going to call that super, and then I'm going to say this dot fly also. And let's see what we get here when we do that. Okay. We didn't do this dot fly did not execute, right? So I only see up, and oh, do we? So we only got the greet. Oh, you know why? Because I didn't call it. That's why. Not going to see it if we don't call it. So here I did the greeting. I'm going to get rid of the console log, the greeting. Boop, we're not doing that anymore. I'm going back to walk. And there we go. I hate when my segue is in the shop and up, and away. Okay? So outside of the method, we could have called greet just by, or when we instantiate the instance, if we wanted to call one of the methods that are being inherited, then we utilize it outside as dot notation. Once again, I could do classy greeting right now or set hair color. We could do that. If I wanted to create or override methods, then I could create the brand new method, and that overrides the method that I inherited. Right? I am this new class, and so if I want to be different in this aspect, then I should be allowed to be different, right? If I choose not to override or create my own method for greet, then I will inherit the other method for greet, but maybe I want something different. Here we're trying to do a different walk also, and this allows me to inherit. So super inherits, super is the parent, I'm going to put here, or super references the parent object. References the parent object, right? Or the object that we inherited from, okay? So without extends, we wouldn't need super. Like super says, hey, you got something that you actually inherited properties from. And super's like, that's the thing that you inherited from, okay? So we're able to kind of instantiate that previous method as well as extend our method to do whatever else we want it to do, okay? So I'll give you a moment to jump into that. Who wants to put an emoji there? Because I'm not going to put my emoji. No one's clicking on my emoji. Not going to be insulted. Maybe a little bit
Joe,
insulted.
are your feelings hurt? I feel like your feelings are a little hurt.
Is there a little hurt emoji feeling? I want to feel like find the emoji where their heart is breaking in half. Or unicorns, man. I like it. See, that makes me happy. I'm back. I'm back, Justin. You just turned it all around for me.
So really fast, you only use super when you extend the original.
Correct. So extends, I'll just maybe make a note of here, extends and super will be used together, right? Now you saw that we didn't need to use super until we wanted to kind of instantiate a method from the parent within one of our own methods, okay? So they will be used together, but if you didn't need to do what we were doing, then you wouldn't need super, right? But if you did use super, the context of super means, if you want super.walk, then you don't want the walk that's inside of superhero person. You want the walk method that's inside of the parent that you inherited from, right? So if I did the little annotation, I think I figured out how to clear out the annotations. It's looking at this thing right here, right? It's going to find the method that is in there, okay? This context of this, like this one right here, this context is looking at superhero, right? So when we reference this, this is the current context where you're at, right? And super represents the parent context. Now, undo everything. All right, sweet. You good? 17, 18, 19. So you got 19. And the way that we're creating these classes now is something that you will revisit once we get to React. React uses ES6 classes as its fundamental building block. They actually call the classes there, take on a new naming convention. They are classes, but they're called components. So they take this new naming convention, and components can actually be two different forms, classes being one of those forms, okay? So this, what we're introducing now, you will use it, you'll be using it going forward, but you'll see it even more prevalent when we do get to React, okay? All right, looks like we're good. So let's go to the next one. So now we have the most use, the word super though, here is mostly used or useful in the constructor. So in the constructor here, so our superhero yet has not been given a constructor, right? And what is the constructor going to allow us to do at this point in time? What is the purpose of a constructor? Can anyone tell me why we need the constructor?
if we wanted to make two people
Okay.
or have two, two sets of everything.
So I like where you're going. I think originally when we created the person, I was able to instantiate a me and you, but they didn't have any properties, but I was able to instantiate two separate instances of the class without the constructor. So what else? Just by looking at this picture, right?
It's also good to replicate.
Okay. So, I mean, the fact that
properties.
What's that?
So it assigns properties, right?
Correct. So in order for us to get some sort of arguments into the class, right? It's no different than this. The constructor kind of acts like our conduit into the class to pass data into it when we create it, right? So if I had a function and I was like, hey, super person, I'm just going to do the super person, and I wanted to give a name, I would do that, right? And in essence, this is how I would get the name into here, right? That's how we would get it. We'd create a parameter, and then I would call this function super person, and I would say Joe, right? I'm the best super person ever. And then by giving it an argument, this gets passed into the parameter, and then we can call it here. So the only way to get something into the function, into the body of the function, the only way to do that is to pass it through this little door. That's what it is. It's a little doorway to get things in. Now, when we're working with classes, well, classes are written differently. They're not written like functions. And so the question is, how do I get values into this thing when I instantiate it? The constructor is the way that we do that, okay? So in here, the fact that we passed in these values, well, these values got passed in via the parent's constructor, and so we inherited that. Now, that's not a big deal, right? So what we can do now is also create our own constructor and say, hey, we want name, age, eyes, and hair, okay? And we're going to kind of tie those things into the parent. So I'm going to say, if we do get these in, we actually have these properties being inherited from the parent as well. So we just want to make sure that the parent gets them now as well, because we kind of like are bypassing the default behavior. Now that we're calling the constructor's like, hey, I control now the values that are coming in, and I'm responsible for like handling that, and I will pass it on to the parent, okay? The fact that we've just added this, we're kind of taking on the responsibility of passing these values to the parent itself. And we'll see this in a minute. So I have super, and so super now is kind of like, what would you call super? The way super is being used here, what does it look like? If I was to be like, hey, what data type is super here? What does that look like?
It looks like a function.
Right? That's exactly what it looks like. It looks like a function where I'm passing in some, or a function that is taking in arguments. These are arguments, right? Because these would be the parameters that got passed into the constructor, and they're going to be values at some point in time, right? Name, once constructor is instantiated, will be a name. This tangible name thing would then get passed to super as the name that you passed in, okay? So we would instantiate under the hood something like this. Super Joe, 21, I'm really young, blue, black. That's how super would be instantiated here, right? We'd call super. These properties would have already been passed into the constructor this way, right? We pass it in here. They get passed into here. We pass it to super, back to the parent, because that's where those properties are being created, right? So this is what it would look like under the hood. And here I'm also going to add some additional stuff. This dot superpowers is equal to, and then I'm not going to write all this stuff. That's a lot of superpowers. So I think I'm just going to copy the superpowers there, put them here, right? Those are his superpowers, okay? Once again, I'm just going to put a semicolon here, just kind of in that line, and then, there's a semicolon there. So what we're doing now is we are creating new properties that are part of our superhero. We are also, or should have inherited all of the other properties. And let's take a look to see, because we know that parents, this person, also has love cats and love dogs, right? Now, we didn't put placeholders here for love cats and love dogs. We're only passing on name, age, and hair. But we have this dot superpowers. So if we console log Superman, let's see what we get. Okay, and there we go. We got all of those properties that were passed in. We have the 2 default properties that we're inheriting. Right? We didn't give any placeholders for those. We're just naturally inheriting those. And then we have all of our superpowers, a new property that we're using, and we're using the this dot keyword, right? This is how we defined all of these properties using the this keyword. And that's how we're doing it here, okay? Now, what if I did this? What if I console logged out super? I just want to see if we would get some sort of error message, and then we can kind of deal with that. Oh, here we go. We got a must call super constructor in derived class before accessing this or returning from derived in constructor. It's like, what? That's insane. Like, what does that mean? That just means get your super activated. Get your super there, otherwise it's not going to work, okay? So must call super constructor in derived class before accessing this. So it won't allow us to access this until we call super. That's kind of what it's saying. Awesome. What if I got rid of these here? Let's just take a look. What if I got rid of the parameters there? Would we have any issues here? Yeah, we're going to have issues. Name is not defined. So it's trying to pass name, and it's like, whoa, I don't have name. All right, cool. What if I got rid of the parameters here, right? Which these aren't really parameters at this point in time. These are arguments that we're passing in. Okay, let's go back here. Okay, and what do we have? I got a bunch of undefineds. Because once again, name, age, eyes, and hair are coming from the parent constructor, the person constructor. And the way that we pass those things to the parent constructor is within super. Super is almost like we're calling the parent. So I need those values to be there. Or when we instantiate this super, this person right here, right? The person constructor, name won't have anything. It'll be undefined because we never passed anything. We're saying give me a property of name, but we didn't give it a value. And so it's like, hey, you didn't give me a value, so I'm just going to default to undefined, because if you don't give me something, I default to undefined. That's what we do. Okay? Super cool. So I'm going to give you a moment, catch up, build out the final things for your superhero.
Joe, can you just move your page down so I can?
Oh, sure.
Thank you.
Good thing. Okay.
Sorry, Joe. I think I need you to move down a little more.
Okay.
I'm trying to just replicate what you just did.
Sure. I mean, this is as far as I go down.
Oh. No, I'm looking
Yeah.
in the wrong place. Sorry.
Can only help so much, Aaron.
I'm not with it. I'm not looking at the right place.
That's okay.
Joe, really fast, can you just explain one more time in the very last section right here? You just added the constructor and super to do what? Make it all come together, pretty much?
Yeah, so think of the constructor as being a way of us passing in parameters directly into this particular class, right? Just like the constructor up here was used to pass in parameters to person. Anytime we use that constructor keyword, it is meant to act like the function. Remember when I created this function down here?
Mm-hmm.
So let's just say I called this constructor, right? Constructor. I'm trying to emulate what's happening here. I'm trying to say that if I wanted to get something into my class, I would have to pass it through the constructor, right? So the constructor in this instance I'm simulating is a function, which is what it is up here too, right? This is a function, and I want to get something into my class. This is the only tool that I can use to get something into my class, okay? So without a constructor, I cannot accept any arguments. You cannot pass me anything unless you give me a constructor, okay? And just think of a constructor as being like a door to your house, right? Your house can have many doors to get in or windows. It's an access point in, and then we can say, hey, this is the front door, that's the back door, this is a window, this is another window, and people can go through this door, people can go through that door, right? But without creating this concept of an entryway, a portal into our class, there's no way to pass something in. Then super is just saying, hey, I know that you're not just you extended something. Like you have a parent, and your parent is person. The person also has a constructor as well, and they have some values that you're inheriting from. If you want to inherit those properties and combine them with the values that were passed in to your constructor, then this is how we do it. So when we actually call super here, this is actually how super is running. It's taking the values that were passed in, and it's actually literally passing those values to the parent constructor. The parent gets them, and then the parent's like, oh, hey, we got this thing. They want to instantiate a new superhero, so they need me to like grab some values, put them with the properties, and then send that down so that they can inherit these properties. Does that help?
Yeah, thank you. And just to reiterate that the constructor is only for whatever class you put it under. So
Correct.
It's looking for that specific one.
Yes.
Okay.
So it only works for the specific class that you instantiated for or you created for, right? Originally, when we created this, Superhero didn't even have a constructor, but it worked just fine, right? Mm-hmm. So what happens with the class, it says, hey, you know what? If you didn't include a constructor and you extend from person, then I'm going to go look in person's constructor. I'm going to go look in their constructor and see if they have placeholders for these values that you gave me. And if they do, awesome. Everything works copacetic. If you then say, hey, you know what? I want to create my own doorway in, then this says, all right, well, I'm not going to be using their constructor by default. I will use your constructor by default. Okay, so if we happen to forget to pass in these values, if I was like, hey, I'm not going to pass in eyes and hair into my constructor, let's just see if I would be able to inherit those properties with any values. Oh no, it's like unexpected super. Oh no, here. That's because I have one extra here. Clear this. What was it? Eyes is not defined, right? And it's like, all right, because super here is trying to pass values to the parent, and it's like, I'm expecting a value here, and I'm not getting that value. And if I don't get that value, how do I pass it to it, right? I'm only passing in name and age, but I'm not passing in eyes or hair as values. And so super is like, whoa, we just can't call this function and pass these things that don't have values. That's going to break. So we need to pass those in order for this to work, okay? And you can see eyes is not defined at superhero. That's where it's expecting superhero or where eyes to be defined. So we just can't pass in empty values that don't exist. But in the end, super references this parent class here, right? That's what it's going to reference. And these two, so just so that you know, when you do create the classes, you know, outside of this, wrapping your head around constructor and super and this really become the main things that you just have to understand. Outside of that, creating methods, defining properties, those are the real easy things to do, right? I mean, I could write whatever code I want in here. I could write a for loop now that loops over things, generates new hosts, and does things. Like I could do whatever I want inside this method. The things that you really have to kind of grasp your mind around here are these new things like constructor and super. And if you can just learn to like write the constructor and the super and know that these things should be passed in, you're going to be on good ground with that, okay? You're going to be on solid ground. And just, once again, knowing what you're doing with those things, why they're there, is also a good point. I had an interview maybe, I don't know, 2 months ago. And the interview was, they showed me a React component, which is basically this. In all honesty, it's a real class. And they said, hey, I want you to walk me through what's happening. Tell me everything that you see here and explain it. And so I had to explain what the constructor was doing. React uses extends. You extend the React parent component. You create your own. So you extend the class and you create your own. And so I had to explain, oh, well, the constructor here is how we're going to pass in values. Super is calling the parent, and that's how we can pass in values to the parent. These are additional properties here that we're defining. This references the context of the current thing that I'm instantiating, all of those things. These are some methods, yada, yada, yada. So I had to walk through a React component, which is really something just like this, okay? And explain what was happening. Cool. Feeling good?
Joe, I have a question.
Sure.
Is there a limit to how many classes we can nest within other classes?
Nope.
And then my second question is, if you use, assuming we have more than 2 classes, when you use the term super, which parent is it going to refer to? Is it just the parent, or like will it go further back?
No, you're only going to inherit from one specific parent. So say I'm doing this inheritance, right? I kind of like the annotation thing now. It's pretty cool. So if I have this thing, and this thing has a child, and this thing has a child, right? Just say these are classes, right? Individual classes. If this inherits from this, then when it calls super, it's calling that. When this inherits from this, when it calls super, it's inheriting from that, okay? So we can inherit and keep inheriting things down, further down. But anytime you call super here, so if I did call super, you know, I was looking into using my iPad in the afternoon, so I think tomorrow I'm going to have this all done with a pen. If I call super, I'm calling this, and then this would be a different super. So you can create as many objects as you want, you can have this inheritance to keep going as far as you need and pass down these properties further and further down. It's just like a car. If I create a car, I can have a sports car. Sports cars can be maybe broken down even further into different categories. All of them inheriting from the sports car parent that inherits from the parent, right? And we can just keep sending these inheritance properties and methods down that can then get overwritten, right? So a normal car has an engine, is a 4-cylinder engine. Sports car is going to have a 6-cylinder engine, I don't know, and a Ferrari is going to have an 8-cylinder engine. And so you can change and manipulate these properties as you go down. That make sense?
So we can have multi-level inheritance, not a class inherits from multiple parents.
So yeah, you're not going to, this one right here is never going to inherit directly from here. That is a no-no. That'll never happen. Or in this instance, I'm just saying the way I have things created, I'm going to inherit from here just based on the architecture, the design that we came up with. If I wanted this to inherit from here, then I would need a different structure. Then I would need this scenario, right? I would need to do something like that if I wanted both of these to have the same parent. Otherwise, I can only use this extends keyword once, one time for the class itself. I can't extend 2 classes at the same time, but I can get the properties from this class here to down here via the parent. If the parent has it, then I can extend it all the way down to the parent. Does that make sense, Pooja?
Yeah, thank you.
I know this is, this isn't an easy concept. Clear. Clear against. But once again, once you kind of get it, and you understand that one class can extend only one parent, that constructor is the way that we pass in parameters into our class, and that super is always referencing the parent thing. And without super, we don't have a context of this also. If I got rid of super right now, we'd also break. If I got rid of super here, we'd get the same error message as we did before about this. So if I get rid of this, I'm going to get the same error message that must call super constructor and derived class before accessing this. It won't allow us to access the this keyword in the constructor without super. Super somehow knows that you've extended a parent, and because you've extended a parent, you need super. When in the person class, we don't need super here, right? There's no super, and everything works, and we can use this, but not here. The minute you include the extends, in order to access this keyword, you need super. So just know extends and super are intertwined and kind of married forever from this point in time. If you don't include the keyword extends, then this is how you will build your class. It's devoid of the extend keyword. It's devoid of the super keyword. They are not used. They are not needed here, okay? But we might even error out if I try to incorporate super in here. It may be like, I don't really know what you're trying to do. Super what? Like, you didn't extend anything. How are we feeling? Any other questions? These are good questions.
Said something about only using extends once. What were you referring to when you said that?
So when I create this parent, right? So I'll just go back to the annotations. When I create this parent, right? Because it's the parent, it's the top level, there is no need to use the word extends, right? There's nothing to extend. There's nothing above it because it is at the very highest level. Then I have this child. This child wants some of these properties and methods. And so the act of doing this means we extend, right? I can't really write it. So I'm just going to put EX. We extend it once. this thing can extend itself to inherit only one instance of something else. I'm just going to clear it. Yeah, this. See here? The extend keywords can be used once on the superhero class. You have to make a decision. When I create superhero and you're like, all right, I want it to inherit from something, you have to be like, all right, it can inherit, but I'm telling you now, it can only inherit from one parent. So you make the decision when you're creating this structure of inheritance. Make sure that the thing above it has the properties that it needs. And if it needs additional properties, then maybe this thing over here needs to extend another parent. And you have this child, you know, you have a parent, you have a child, and then you have a child of the child. And that does happen in you know, because you're creating these things, there's going to be complexity to an application. And this is just one way to structure. This is really a data structure, right? It's a thing that we can use that's a self-contained thing, that if we instantiate new instances of it, they have these properties, they have these methods, they can do these things, and they become unique instances of this. Cool. Any more questions? Going once.
I have a question.
Sure.
So, like, breaking this down, well, I guess I'm kind of confused how to ask my question.
All right.
Like, all right, so when you're doing an object, you're defining essentially just an object, all of these things. Like, you're giving it these properties, you're doing this, and then you can set functions. I guess how versus what we're doing with classes, is it like you would use one, or like in certain situations you would only use a class, certain situations you would only use an object, or like is it like one of those things where these are interchangeable, if that makes sense?
So yes, so it's a really good question, Aaron. So creating a class requires a bit more overhead for the server. It has to create this, load this thing into memory, and it requires just a bit more processing, a bit more memory when creating just a plain old object. So just a plain old object, dumb old object, let obj is equal to an object. Doesn't require as much as doing this. Plus, this requires a lot of typing as well, right? I got to do class, superhero extends, this, constructor, yada, yada. This is a bit more complex. So a lot of the times when all I need to do is spin off a object, a really basic object with like 2, 3 key value pairs, then I create an object, right? In a looping construct, I would do something like, if that was the case, maybe I would do like just a for loop, and I would do, you know, let I is equal to 0, while I is less than, I don't know, 3, you know, I plus equals 1. And then I might do something like this. Hey, return a new object, or push a new object into something. Well, we're not going to return it, right? Because this is we have to get it into something. So maybe let R is equal to an empty array. And then we could just do like something like let obj is equal to this object, and maybe like number is equal to I. And then we can just push this thing into r.push obj, right? This thing is so dumb. It really doesn't have a lot of stuff to it. Doesn't need to inherit anything. All I'm looking to use this thing for is to keep track of the numbers. That's really all I'm trying to do. You know what I'm saying? Nothing more than that. The current number. Maybe I want to include the sum of the values as we increase, whatever it is. And then if we just, you know, console log array, right? I have just these dumb little objects. They suffice to do what I'm doing in this instance. And I almost always, in just daily coding and figuring out small, tiny solutions to things, I almost always use just object literals versus classes. Classes are more for when I'm really thinking about in greater detail the development of an application that requires very, very solid structure. And creating these things insinuates that they are things now, not just dumb little objects that don't really have any names. I don't need these things to have names. They just are, they're an object. I reference it in an array and I get its num value. That's really it. But if I'm going to create a game, I'm going to create a superhero game, then sure, I'm going to create Batman objects and Superman objects, and I'm going to instantiate those instances as people play the games. Just think of something like Fortnite. Has anyone heard of Fortnite? It's probably like one of the most popular free games.
I was going to say, yeah, everybody plays it. I don't, but I know, like, everybody I know does.
Everybody plays it. Man, I wish, these are one of those things. I wish I could go back in time and had learned whatever coding language they built Fortnite in. I would have built myself a skin or some sort of like shopping cart or a rocket and sold it, and I could be a millionaire right now. Quite literally, people buy these things online for $1. You have millions and billions of people playing this game. So just think of Fortnite where you have the same kind of characters that are being instantiated. I'm here, I create this one, I pick the skin, I pick the character, boop. You pick the character across, you're all the way in like Australia and you pick the same character. You know what we're doing? We're instantiating a new instance of that character. The character has certain properties about them that are going to be identical for both our characters. But there may be something where we can say the skin type. And I can have a black skin, you can have a white skin, I can have a technicolored skin. And all we're doing is changing our skin color, but we are essentially the same thing. So instantiating new instances of these things makes it easy to build out a game like that. Okay, instead of creating dumb objects and like pulling together properties and being like, oh, you want to be that? All right, so I got to grab all these properties, put it together, and then create the new thing. This thing already has them aggregated together in one thing. That's where it makes the most sense.
Gotcha. Okay. No, that actually makes more sense because I get what you're saying.
Sweet.
And like with inheritance too, you might create like a master class or like an administrator class, but then the subclasses, you might not want them to have access to all the stuff that the administrator does.
Yeah.
You might only want them to have some of the functionality of the class.
Yeah, you might reverse that, Jeremy, and say I create a user class and then I have an administrator class. You know, an admin is really a user, right? So I can have a user and then I can have an admin, or I can have a power user, like an admin, a user, power user, admin, right? Where the admin inherits everything from the user, everything from the power user, but now the admin creates its own additional methods that extends the power user and now has all of this additional functionality. You start with like the most basic thing, and then at the bottom of that hierarchy is the most specific thing. That's really how it would work. Inherit, 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 change, define, add, overwrite methods. That's the concept. We good? So we're going to go on break. Okay, so don't have any more questions here. It's 4:06, so why don't we come back at 4:16? Okay, channel. We'll come back at 4:16. I was just going to broadcast the channel. On break. Be back at 4:16. Boop. Cool. 416. Let's do it. Back in action. All right. Extends. I'm going to get rid of this little demo here. I don't think we need that. We're only using that demo to kind of convey when a basic object is needed versus creating classes, right? So I'm going to get rid of that. Any other questions on inheritance that you might have had? You might have on break, you were looking at stuff going, I don't know, explain constructor and super again, Joe. And I'm fine. Like I can explain it as many times as I need to, to help you understand it. It doesn't in any way like bother me that I have to explain constructor and super because they're really hard concepts. So I'm game to try the best way to like rephrase things, change up context if need be, to the best that I can. I mean, I feel like I can only explain these in so many ways. I like the fact that we can draw now. It's pretty cool. But if not, then we're going to get into one more lecture, and then we'll jump into the lab. Okay, so we're going to move on to factories. Factories. Okay, so I'm going to go over here. Before I begin with factories, I'm going to touch factories.js. So I have a new factories file. I'll also move this up a little bit. Put this bad boy down here. Boop. All right, move this up. Sweet. Okay. Factories. Cool. So, object-oriented programming is allowing us to create parents and instantiate instance of those, have children inherit from their parents. And so there's a concept in coding called factories, and factories produce things. So we're going to create a factory and, in essence, produce things, right? Just like conceptually what it means is exactly what we're doing. So somebody comes to me and is like, hey, I have this idea of a fidget spinner. And I'm like, I'm a factory. You know what? I'm going to build a factory here in China, and I'm going to build this one prototype of a fidget spinner. And then I'm going to create another factory in the United States and build the same prototype, right? Two separate factories in two different locations, instantiating instances of the same prototype. So the factories themselves are identical, and the things that they're producing are identical. And so we have this thing for like, hey, I have a factory class, and this factory class is meant to instantiate instances of fidget spinners, okay? So each factory can instantiate different instances of fidget spinners, but they are still the same kind of factory, right? So we'll create a factory, and we'll talk about adding some static properties for a class as well. You don't see it done too often, but they're there. So creating a factory. Sometimes we need to have a factory object that will generate other objects, okay? Easy enough. The purpose of the factory is so that it can control the creation process, just like a factory insinuates it does, right? It's usually a single object that exists throughout the program that performs the same thing. We call the factory produces the thing. Call the factory produces the thing. So, think of like we're creating users. Maybe we have a factory that just spits out the users. Spit out a user, spit out a user, spit out a user, right? And conceptually, it's kind of the same thing. We're going to use probably the most kind of tangible thing that we know of is like a car. So I'm going to go here and create a class car. Once again, the naming convention, uppercase, is meant to insinuate that this is a class. I'm going to give it a constructor, right? I'm going to say, hey, we have a maker, and it's going to have a serial number, right? I'll give it some properties. I'm just going to leave the constructor here. Who wants to tell me what the constructor does? Who's like, I can hit this one right out of the park? Maybe somebody who hasn't spoken. Who's so quiet and doesn't speak? Maybe you're so quiet you don't speak. Maybe that's it. Sarah. I'm just going to call on people. Come on, Sarah. You haven't spoken. What's
I knew you were gonna call.
I just, I hit the thing. I just saw a new group of people, and I'm like, boop, Sarah, your pink shirt just popped. So I'm like,
I know. It gives it properties. Is that it?
okay. I feel like you're looking for validation. Does it give it properties? All right, John, can you follow up on that? Mr. John Phillips, can you kind of follow up on the constructor? Sarah's right. Properties.
Yeah. So you call the class, and then you put the parentheses that have the properties in them, and it actually assigns it. The constructor is what assigns it to the object.
Okay. So when I create a new car, I'm using a specific word. It begins with I. Molly, what's that word? I create a new class of something.
Instantiate.
There we go. Instantiate a new instance of something. Just keep that terminology in mind. If you're using constructors, you are instantiating new instances of something. So the constructor is meant to allow us to pass in parameters into our car, to give it values, right? Just like a function, right? This is no different than something like a function car, and we're just passing in maker and serial number, right? The same thing. This constructor is kind of acting like this. We're allowing things to get into our thing, all right? So that's our constructor. I'm going to have this dot serial number is equal to whatever passed in via serial number, and then this dot maker is equal to maker, right? The context of this, right? The other keyword here is this, and this, what does this represent? Justin, what does this represent?
The class that you're referring to?
Correct, right? The instance of the class. Because remember, when we instantiate new instances of this car, this keyword is going to reference that unique instance of the car, right? If I have two cars that I produce based off this class, this in either car is going to reference this car or this car, right? So that context of this takes on a new meaning depending on whether I'm talking about this blue car or this red car. So the context of this will represent the thing, but at any one point in time, this can be two different things depending on how you're looking at it. Okay.
Does the order of maker and serial number matter compared to this serial number versus this maker?
Oh, you mean the way they're put here?
Yeah.
Oh, yeah. So here they don't have to be in order.
Okay.
Right? Here I could write them in any order I want. They're still pointing to the things that they're supposed to be pointing to. Anytime maker's passed in, maker now is a kind of is a parameter, right? This is a parameter, and inside of the constructor, maker, once it's passed a value, is found anywhere inside of the constructor. We can call it at any point in time. The position of these things doesn't make a difference at this point in time. Now I'm going to give it a method, drive, right? Console log, vroom. Okay, and now we're going to instantiate a new instance of a car. Right? Cool. So let's instantiate a new instance. So const new car is equal to new, the keyword that says that this thing is a class, and we pass in some arguments. This is a Mazda, right? and its serial number is 1, 2, 3, 4, 5. Right? 2, 3, 4, 5. 4, 5. Blah, blah, blah. Cool. Now, we can console log new car. Let's see what we get. Node, and we are doing, node factory. Nope. There we go. So we have a new car, right? Once again, the fact that we console log the car, we see the actual class name as car, and then we see the actual data from the car. We see the properties, but not the methods. So we don't see the methods, only the properties, okay? So I'm gonna give you a chance. Create the car, and then we'll move on to the factors, okay?
I have a question.
Sure, yeah.
New, what's the importance of it again?
So new is the keyword. So let me put here, instantiating new instance of the car. New is the keyword that creates the, or that instantiates the new car in this instance. So new says, I want you to grab the class constructor, I want you to pass it these values, and I want you to give back to me a brand new instance of this car, right? So new car is in itself something different from the class constructor, right? The car constructor. Its parent is the car constructor, but new car is its own thing, right?
Okay.
It itself is not the car constructor. It itself is an instance of the car constructor. And new is how we tell JavaScript to say, I want you to pass these values in and return back to me all of the things that a car constructor is and give it to new car.
Okay. Okay.
Okay. It's almost like I might even, without saying that it is, but maybe saying something like function, if I said new car 2, right, and I did this, if I wanted to return something, right? Mm-hmm. What does return do in this function? Does anybody know? I think you covered it already. I think Matt covered it, no? Did he not cover it? So brand new.
It like outputs a value from the function.
It returns something from the function. You're absolutely right. It gives back to, a function wants to give you something. It really wants to do that. And return is, the return keyword is how we say, this is what I want to give back to you. When you call me the function, I will promise you, I will return you this thing, whatever it is. The return keyword also stops any additional code. If I did this, console log hello here, hello, this would never run. The return keyword does two things. It returns something from the function, but it also terminates the function completely. Nothing after the return keyword runs within that scope, okay? It's kind of like you just put the brakes on, we just stopped, okay? So the reason why I'm mentioning return here is because the new keyword is kind of like, hey, I want you to return back an instance of this car. That's the best that I can kind of bridge those two together.
Thanks.
Okay, we got Jeremy posted a little car. Everyone click on the car when you got the car constructor all done. There we go. It's coming in. Numbers are going high.
So really fast, you're saying that the method will never be shown in the console log?
Yeah. Mm-hmm.
So why do we put it there? It's only there if we call it?
Correct.
Okay.
You have to kind of know that the method's there and what the method does. And as the developer, you're going to know those answers, right? You wouldn't be working with the code without some documentation on what this car constructor does, right? There's going to be someone put together some README that's like, here's the car constructor, the class, and we have these methods, and we use these methods to do yada yada, right? So you're going to need to know how to use this thing if you're supporting the development of this particular application. Okay, looks good. Looks like we got everybody. Awesome. Sweet. I'm going to just comment out this. Now, let's go ahead and create a factory. Factory. Okay, once again, the idea of a factory is to produce something, to produce some other prototype of something, right? Factory in itself is a class, which is kind of itself a prototype, because I can build multiple factories, right? So same thing, constructor, right? I want to pass something in. What do you want to pass in? I want to pass in the company that this factory belongs to. And so this dot company, come back. Company is equal to company, right? This dot cars is equal to an empty object. So as you can assume, this factory is going to produce cars, and every car that we produce is going to go into this dot cars array, so that our factory, if ever asked, how many cars do you produce? They're like, I produce this many cars. And these are the types of cars that I produce. You can examine and loop over this array and examine each individual car that is created. Being that this is a factory, we want to generate a new car, right? Okay, makes only sense. And so here, watch what we're doing now. I am going to use the const keyword because we're not going to redefine this. New car is equal to new car, this dot company, this dot cars dot length, okay, and then this dot cars dot push, okay. So what we're doing here is this factory is going to produce this car. That's what it's doing. There's not a whole lot going on with this car, but it is a constructor. We can use it to create and instantiate new instances of cars, and this factory can keep track of those cars, right? So before I do the find car, why don't we do this? Const Tesla is equal to new factory. Hey, what's the factory? Well, this is Tesla, right? Awesome car. And we are going to do Tesla dot generate car, because that's a method. We don't have to pass it anything, right? So I'm just going to run this once just to see what we get now. Console.log Tesla. Let's see what we get here. Oh, what do I get? I got generate, oh, because I forgot the E. Generate car. Okay. Easier to just look at error messages, and there we go. So I'm curious why it didn't push, because I don't see anything in here. Oh, you see why it didn't push? Can anyone tell me why it didn't push? It didn't error out. What's wrong with my push method? I type so fast, my brain is like, yeah. All right, so say I put parentheses. What's wrong with this now?
You're not telling it what to push?
Correct. I didn't push in the new car, right? So now, let's run this one more time. And boom, we have a car inside of our cars array, and it is a car constructor. That's the type of object. If it is a constructor that we used, if it was a class, I'm sorry, not a constructor, if it was a class, the object itself, when you console log it, is preceded with the name of the class that we used to instantiate it, okay? And then the actual values of it. So this means the fact that we've done this, I can create multiple cars, right? Okay. I can console log. And now, look, I have multiple cars, and the serial number increments by 1 for every car, right? So every car is going to have the next car that we create is going to be 4, 5, 6, right? This is going to go on forever as long as we push cars into here. Now we can also ask the factory, hey factory, I know you got a bunch of cars. I need a method to like find a specific car. So I'm going to be like, hey, I need to look for, and this is going to, we're going to use the return keyword here, cars index, right? Similar to what we used earlier, where it's using the index of something. So I have to tell it what it is that I want to see. So I have to do Tesla dot find car, and what's the value that we want to pass in here? I'm going to say, I don't know, I want to find the 4th car, which is the last car in the array. Undefined, let's see, maybe 3? I should have found it, right? Find car, index, return this dot find car. All right. So I was doing 4, but I only pushed in 3. 0, 1, 2, 3. There is nothing at position 4, right? I miscounted. This is the thing at the first position. This thing is at the second position. This thing is at the 3rd position. And this thing is at the 4th position. It uses ordinal counting, right? So now I can return back this thing that's at cars. And then I can be like, all right, what's your maker too? I think we can even do that. Now that we returned it back to us, we should be able to get the value. It returned back to us an object. That object has properties. And so we can just get the properties from the object, right? Instantiating new cars. Pretty cool. All right, gonna let you catch up. Create your factory.
Which part of this is indexing or adding 1, 2, 3 to the serial number?
So in our car right here, right? Our car constructor has a maker and a serial number, right? So what happens is this. Our factory produces cars, correct? Every time it produces a car, it gives it the name of the car, right, that we're telling it to create. And it's going to create the same as the company that we created, right? So Tesla, it's always going to push in Tesla, right? So he's going to be a Tesla. So let me just get rid of this. So we can see that it is a Tesla. All right. Nope. Not console log. Oh, because I'm not console logging. I'm just going to console log Tesla.cars. Let's do that. So we can just see the cars. So the maker's always Tesla. So this number changes, right? And that number changes because when we push something into cars, the array length of cars increases by 1. Every time we generate a new car, we're referencing the car length to get the next number to use. And so we then pass that particular number to the car constructor. And the car constructor is like, oh, hey, maker is this company, which translates into Tesla. Serial number is whatever the length of the array was at the time that you called me. That makes sense? We could have done something like this. We could have said, you know, this .count is equal to 1. And instead here, maybe we could say, I don't know, oh, I forgot the dot. Maybe we can even do this. Maybe this .count plus. Let me see if this works. I'm going to set this to 0. Hopefully this works. Let me see. Yeah, see how it's working? It's doing the same thing. I don't have to get the car length. It just kind of makes sense, right? Every time I push a car in, there's a new car. That new car must have the next serial number. So let's just use that. It's just an easy way of doing it. So if I did just 1, so our serial number would begin with 1 now. 1, 2, 3, 4. Okay? Does that kind of help explain it? Or not explain it? Or just like, whatever, Joe, whatevs.
For some reason, I'm logging it, and all I'm getting is literally the word Tesla.
So, let's share.
Apparently, I'm having a lot of bugs today.
Bugs are good now. Let me tell you, bugs are great now. You're going to hate them later when you're working on your project.
I was going to say.
Yeah. All right, so what are we getting? Car is not defined?
No, I'm literally just getting the word Tesla. Like, nothing else is coming out with it. Yeah, I already fixed the error that was there before.
So you're pushing, so Tesla.generate car is this.cars.push. And then when you, because you're just console logging Tesla.
Is it because I put it in quotes?
Yeah, so it's a string now. Tesla becomes a string.
I figured it was something simple. I'm just thrown off. I don't know.
Yeah. Okay.
Sorry.
The place to do it, man. This is the place. How do you think I feel when I try to push things into using push and I even forgot to put the parens? Like, come on. I know how to use push. I just get so kind of excited up here and I'm like, oh my God, go to push. We're going to do this. And then my brain just is 10 steps ahead. I'm a living example to just like slow down. Otherwise you do this and these things drive me crazy because I am my worst enemy right now. The fact that I want to code so fast and just get ahead really prevents me from doing things right the first time.
I have one question here.
Sure. Yeah, Pooja.
Maybe you mentioned it, but I missed it.
Okay.
So, there's factories. Is it something, a concept in JavaScript or just an example that we are looking at?
No, it's actually a concept. So if I go to Angular factories or factory, here, Angular, which is a front-end framework, kind of like React, but it's a much more robust front-end framework, has things like factories and services. So when you start developing an application, you have to really start thinking high level here. Well, what constitutes a service? What constitutes a factory, right? So maybe a factory in this instance is something that outputs a unique instance of something, right? And maybe even keeps tracks of those instances. And a service could be something that's running in the background, listening for requests, servicing, being some sort of service provider. Like you ask me, I get the data, I give it back to you. Something like that. Conceptually, that's what it is. That's how you can read through it. Like there's even a provider, like, I don't know, 3 ways for you to create and register your own service. Like when you're using a factory, you create an object, similar to what we're doing, add properties to it, then return that same object. When you pass this service into your controller, those properties on the object will now be available to that controller. So I'm not going to get into this because this will just confuse the hell out of us, like what's happening here. But just understand that the concept of factory isn't just limited conceptually to this thing like a factory that we know of. It is now kind of incorporated into coding and the overall design of something. So when developers at this high level, like Tyler McGinnis, he's really well known in the world of React, Angular. I subscribe to his channel, watch his videos all the time, really smart dude. When they're developing applications, they are thinking at the most high level how we're going to do this thing. What do we need to do? All right, that sounds like a factory, right? Put a factory. That sounds like a service. Let's write the service. So, are we going to have other things that are going to be children of this? Great, that's a good call. Let's write that. They do all of this design like anyone would. Think like an architect. He's going to build a house. When they're thinking about meeting with the electrician to lay the wires, the electrician gives the input, and then they design the wiring in the house. Not only where the wire goes, the type of wires, the type of outlets, all that stuff gets architected first in design and then built. So you have the conversation long before you build the thing and realize, man, that was the wrong thing to build. right? I saw this many sockets, but we used an inferior code of wire, right? You would see that in the design. A good electrician would be like, hey, if you have that many sockets, this wire right here, it's not strong enough to hold that, and it's going to cause a fire, man. It's going to explode and pop in the wall, right? You have those conversations first before you actually break into the wall and start building stuff, right? It's the same thing with any large tier application. You need strong design first and foremost, and then you build. And that design structure, depending on the application, in Angular, there are factories and services and providers. There may be the same thing in other frameworks as well, okay? I think React has something like that, like really, really advanced React might have that.
Yeah, thank you.
Sweet. Is everyone good? I only got 15, unless we hit the car before that. I don't know. Yeah, now the number goes up, right? Tick, 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 tick. All right. Looks good. So now that we have a factory, right, I can create or instantiate new instances of other factories, right? So I could say here const Porsche is equal to new factory Porsche, right? And now I have a Porsche factory. And I can say Porsche dot generate car, right? And I can do this a few times if we want, right? And then we can say console log Porsche, right? I'm going to console log Tesla also, so we can see that we have both of these things running. And now we can see that Tesla has its own factory that's outputting cars, and Porsche has its own factory, and it is also outputting cars too, right? The fact that this factory was just built, it makes only sense that the first car that comes out of the Porsche factory has a serial number of 1, as well as the Tesla factory, right? First car should have the serial number of 1, and then those numbers increment, right? And so what you're seeing is a good use case where multiple classes are being used together to produce something, right? And what you can only imagine now is that if we had a car and we're generating a car, maybe I'm going to have, as part of the car creation process, right, I may have things like an engine. So I might want to create a class of engine that the car can have, and that engine can have properties. I can create a class of suspension because a car has some sort of suspension. And so now this car itself can be an aggregate of other little tiny classes, right? Just know that everything that we touch, everything that's around us is an object. If I looked at a car, I could break everything in that car into smaller and smaller pieces, and those smaller pieces would have properties to them, right? And so I could reuse the same screw in several different places on the car, right? Nuts and bolts in several different places, the same kind. The tires, they're going to be the same 4 tires. You should never have different tires on cars because they're just different and they wear and tear the tire in different ways. So it's always suggested you have the same tires. So maybe we have a constructor that produces different tires for different cars. A Porsche is not going to have the same tire as a Honda Accord, right? That's not why I'm buying a Porsche. I'm buying it because it has all the top-notch stuff. Cool. I'll go over this last one and then we'll hit the lab. I'll give you a chance to catch up. We'll hit the lab. So creating static properties for a class. Sometimes you want to define properties that pertain to the class as a whole, not the actual instance. And this allows us to limit kind of somewhat the user can do. So here they're giving a instance here where we're using this static keyword. Okay, and the static keyword is saying, hey, eye colors and we're going to just return these values. So when we do want to give Superman an eye color, we choose from these lists of colors, okay? I don't really use static all that often. It's something that you might see. I've seen it. Most of the code that I do look at, most of the code that I've been examining just this last year, the fact that I've gotten into React as much as I have seen things where I do occasionally see something called static. And that just means that this thing has its own kind of unique property. In this instance, it's really kind of a method, right? This is clearly not a property. It is a method. And we're kind of giving it this unique thing that all the other properties, all the other instances will have, but yet this thing remains static within them. It's not going to change, and they can't change it. And if we want to reference this person thing, we have to use the person class name in order to get it. See how this person is a class, and we're instantiating a new instance of superhero, right? But I can go into the person class and elicit a property from it, right? Or elicit a method from it, okay? So that would be to say, if I was to go up here and say, I want to elicit the drive method from car itself, right? Because that's what it looks like it's happening. Let me see if we could do that. I'm gonna just stop all the console logs just so we can see if that's possible, right? So I have this car. So what if I try to do that? What if I said, hey, car dot drive, right? What if I did that? Let's see what would happen. Car dot drive is not a function. What? How is that possible? Right? I know it's a function. I know I can use it elsewhere, right? If we instantiated a new instance of this car, if I was like to say const new car is equal to new car, maker is maybe, I don't know, Toyota, serial number will be, I don't know, 100, right? If we instantiated a new instance, I could do new car dot drive, and we should see vroom, vroom. And we see vroom, vroom, right? These methods are only accessible after the instantiation. That's the only time we can do it, is when the thing, a new car, has been created. But we could say static and give it some things. So let me see if we can do here. Static, I'm just going to create something. Okay, static color is equal to red. Let's just see if this works. I didn't see the color coding change. I think maybe because we have the constructor, that may cause a problem. Yeah, unexpected equal token. So I think, let me see, if this may have to be a method. Maybe I can't just do properties. It has to be a method. Yeah, so it has to be a method. So I'm going to say static color, and how about we just return red. Let's just try doing this. Okay, red as a string. Okay, so now I know the thing is working, right? I just want to make sure that nothing's broken. Now I'm going to say car console.log car.color, right? Let's see if we get red. Do you see? Anything that has a static property here allows us to call on the parent instance without instantiating new instances of the thing itself. Okay? This is an act of instantiation. This is an act of actually calling the class and asking to execute a method immediately without needing to have instantiated something first. Okay? Once again, it's not the kind of thing you're going to be using quite often, but it's good to know when you see it. If you do see it, you're like, oh, and then ask yourself, if you see that, the question that I would ask myself as I'm looking through code is like, why did they do that? How are they using that? And then see in the code where they're doing that and say, oh, now I understand why they're doing that. Okay? I don't see it done too often. So I'm just saying, you will see it, but I don't really see it too often. So I don't really have too many examples of when this is used. I'm going to try to find an example. I've seen it in some D3 code that I've looked at. One of the guys I follow had done this a few times. And I knew at the time when he did it why he did it. But off the top of my head, I don't have the example. I'll try to find it.
Hey, Joe.
Yeah.
I don't know if you know this. I'm probably telling you something you already know, but I notice you always type out console log. If you do log tab, it brings it out for you.
Oh, sweet. Awesome. Yeah, I don't use Atom. I was using Sublime like forever.
I figured. I was going to say, I thought I remember you saying you don't really use Atom that much.
Yeah, I use it now for this class, because that's what the team uses. So I was like, hey, you're using Atom, I'll use Atom. I don't want to confuse anybody. So yeah, I've seen a few shortcuts. So I gotta learn to pick up on the Atom shortcuts. So I appreciate that, Aaron, because I get tired of I don't want to type out stuff.
That's what I figured.
You see, if I could have had done push into the array, I would have is there a push method? I just and it does it. How we feeling? I'm feeling quiet, Joe, on the inside. All right, how about this? How about we shoot out? Oh no, that's not the poll. I think it did too much, so I'm gonna delete it. That wasn't it. Did I a bit lost? No, I think this is it. How are we feeling? Let me see if I. Edit the message. That looks like the poll. Poll, how are we feeling? Good. Maybe I need spaces here. Let me see.
That first quote for how are we feeling, it's a single quote.
Oh, it is a single quote. Okay. Oh, that's why. Yeah. I think I originally did single quotes and I went back, changed it, and now it's not even doing anything. I think I have to repost it. Copy. Cancel. Let's see. There we go. All right. Getting there. I'm good with getting there. Getting there's good. Good's even better than getting there, but once again, everyone's at their own pace. Awesome. Well, you only get there from getting there and good to feeling great by doing more practice, right? That's what it's all about. So, hey, Joe, we want a lab. What? I got a lab just for you. That's awesome. I'm glad you asked. So, I'm going to hand out the afternoon lab. All right. So this lab is about, as you can imagine, classes. And as you can imagine, inheritance, right? So if I have a class of pet, that seems like that's kind of some sort of parent class. And then I have a dog. Last time I checked, a dog is a pet, right? Last time I checked, a cat is a pet. So this pets class contains things like owners, the name of the pet, and maybe a walk, right? This thing walks. Every dog has an owner. Every dog has a name. Every dog, last time I checked, walks. Cats, the same thing. They all have owners. They all have names. Then they all walk, unless they're strays, right? And then for a particular dog, dogs chase their tails. That's just kind of what a dog does, right? Get the price, returns a price for the dog, maybe how much you paid for the dog. Cats and dogs bark, right? Cats purr, right? They clean themselves. There's also a price, right? So you're going to create those, update one property of the dog after it's been created to log and to check and update a property of the cat, right? Now the stretch goal here is to use classes to generate, something different, but similar. If you can complete this, then the the kind of bonus is to create a deck of cards using classes. So you can imagine like maybe a deck is a class, right? And a deck produces cards which are classes in and of themselves, right? A card can then have a value. It can have a suit, right? It can have a color as well. So in this instance, we could possibly have two separate classes. One class produces the other class, just like our factory, okay? And they kind of walk you through some of the things here. If you are done with that, there's even a super bonus. What? A super bonus. So this super bonus is doing Hangman, okay? And Hangman has a game class. It has a letter class. It has a word class. And they kind of tell you the construct of these things. So if I'm going to create a letter class, it's going to have a value. It's going to have this hidden value of a Boolean. It's going to have a show. It's going to have a display. And from it, you would create those objects as needed. Okay, that's the bonus. Super, super duper duper bonus, right? So you're going to start with just the first one, and I'm going to slack it out and then create the rooms. So give me a second. I will create the rooms. Breakout rooms, breakout rooms. Let's do this. Boop. I'm going to recreate all the rooms. And you ready? Actually, no, why don't we do this? Why don't we take a 10-minute break? And then we'll hit the breakout rooms because you guys should take a break, right? Yeah, I get lost in like, I could keep going, blah, 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 blah. But I know we all need to take a step back. So why don't we come back at, say, 5:10? I know that's only 7 minutes, but I want to get you into the lab. So 5:10, we come back. Cool? 5:10. Should be back on in 1 minute. Tweet, back on. Okay. I'm going to shoot out the breakout rooms. Let me just make sure here. It has to be in the same one. O2, breakout room 10. Okay. Sweet. Send out the breakout rooms. We're all set. So we're going to come back at 5:50 to assign the homework. Okay. So everyone come back at 5:50. I'll post in the channel. Reach out if you have any questions. I can jump in one of the rooms to help out. And you're off to the races, people.